today. Boy, I'm really setting up for a great day, aren't I, you know? So all your professors start their classes? You're going to love today. We're going to have a great time. No, it's just not a horrible concept, and it may very well be some things that you did in 112, but this is where I find students have the most difficulty with MATLAB, and it is the whole concept of passing arguments into functions and back out. So there's not many slides today, but I may spend like, 43 minutes on each one just to make sure I guess that wouldn't be good. That would be like 11 o'clock, well past my bedtime. But a long time in each one to make sure that we all know what we're talking about. No, I do not know why that happened.
That's me.
Oh. You can control this from you?
Gee. I can turn it on and off.
Okay. You have like all math. This is very scary. Okay, so I should get to my own notes. What is the big concept today? What's the big picture? What's the thing that you need to walk out of here today with? It is the concept of passing things into functions, functions passing things back to what we will call the base. Okay? I will say that several more times because that is exactly the thing that we get confused about. First of all, let us get out of the way something that is not what I would just talked about. And those are scripts. Scripts are just a series of statements. They are stored in a separate file, a .m file, normally. And they are simply run as if you were sitting there at the MATLAB workspace, the command window, typing those commands in. Okay? If I say something that you already know today, that's all right. That's, one less thing for you to have to learn, right? You already know it. I am not assuming that you do know it. I'm not assuming that you do not know it. I am just making sure that we are all on the same page. Scripts. Script is just a separate file that holds a series of statements, and those statements get run as if you were just sitting there typing them into the command window. Okay? Much different than the thing functions. That's the thing that tends to confuse people. Okay, so is this a separate slide? Let's just, I don't think so. So I'm just going to double check. It's not. All right, I'm going to do something real quickie. Okay. Here's an example of a script file. Notice, first of all, in contrast to what we'll do later, there is nothing in this file that says I am a script. It just basically starts with comments, and then once done with the comments, it comes right down here and just starts doing its stuff. Okay? For now, I am not assuming that you necessarily need to know the whole if, else, for loops, all that kind of stuff. You may have done it in 112, that's fine. If you have, great. If you haven't, that's fine, because that's not what we're talking about in this thing. What we're talking about is saying, again, those statements are just started. They just are started writing as if you were just typing them from the command window. This is possibly the most exciting script you ever saw. It converts temperature in Fahrenheit to temperature in Celsius. I could not imagine a more exciting thing to do a Wednesday at 4:15, but it is here just for illustrative purposes. Okay? What is the most important thing about scripts? Let me tell you. When you start doing assignment statements within the script, those variables that you assign will be visible to you back here in the workspace. Okay. Let me say that from a different angle. I like to say things multiple times from different angles. First of all, let's make sure we have our terminology correct. This big thing here, which I type commands into, is the command window. That's what I call the command window. And this is the workspace over here, which shows you the variables that MATLAB currently knows about. The script function, again, is a separate file. It's a .m file that has to be within the path that MATLAB can see, much like the .p quiz file, which maybe I shouldn't talk about anymore because I start to feel my blood boil. It doesn't work still. You run a script file. How? You run it by typing in the name of the script. It's in little tiny print, but this one is called Fahrenheit to Celsius. And you type that at the command window. As soon as I type that, now you may remember, or you can go back and look at your slides from the first time. If I just type the name of something, what does MATLAB do first? It first sees if, well, let me ask you, maybe for a little bonus point today. I type Fahrenheit to Celsius, I hit return. What is the first thing MATLAB does? Bonus point, right there. Okay, it looks to see, is there a variable with the name Fahrenheit to Celsius in my workspace? And in this case, no. The next thing it does then is start to look and see if there are files by the name Fahrenheit to Celsius.m in the path. And in this case, yes, there is. And so then it will start executing those statements as normal. Okay? Again, it's not the point of this particular little demo to say, okay, you need to know how that script works. I know you have that in your, hopefully you have that in your notes, but that's for a different reason, which I'm about to get to. It's more important that you know that the variables that are created or ever assigned within the script stay in the workspace. For example, notice here that once I ran this, it has two new variables in here, temperature C and temperature F, and that is because there they are assigned right there within the script. So when the script is done and I'm back at MATLAB command window, they are there. Those variables are there. I wonder if you have any questions about that. I have much more to say about that, but I wonder if for now if you have any questions about what I just said. You might be saying to yourself, I don't know what you're talking about. I don't even know what question to ask. If so, that's good. We're going to keep going on. If it's all very clear, that's good. We'll keep going on. Okay? All right. Next major thing. New topic, very much connected to what we were just talking about. The concept of workspaces. Okay? A workspace is simply a collection of variables. MATLAB could hold several of them at one time. If you just start MATLAB and start typing and start assigning variables there in the command window and never do anything like run scripts or run functions or anything else, you just mess around in the command window, then all of the variables will be in what we call the base, B-A-S-E, base workspace. Run MATLAB, start it up, you're in the base workspace. What would be an example of another workspace? We're going to get to that. For now, the important thing is a workspace is a collection of variables. You may have another workspace that has another connection of variables. The two may not know about each other. Certainly, the two will have separate variables in them. Okay? I want to hold Fahrenheit to Celsius dot PDF. It's not there. Oh, I know where it's not. Do you have this file on Canvas? Does this exist? Do you have something called Fahrenheit to Celsius.pdf? Or a slide that has basically what you see here in front of you? Okay. If not, then I don't want you to worry too much about, oh, I got to write all this stuff down real quick. I'm giving you, I will provide this file for you. It's my mistake that I didn't get it to you in time for class. Let's talk about what's important in this particular file. Slightly new topic, by the way. We moved on from scripts and workspaces, but they're all connected. And now we're talking about good documentation. What makes a good script if you were to write a script? The main thing is all the things that you put in it that help you know what it's about 6 months after you wrote it and have completely forgotten about it, but you want to go back to it, or somebody you want to share it with. So again, keeping in mind, I'm giving you this exact PDF, so don't worry if I go too fast with it. You've got the you've got the lecture, and you're going to have you got the recording, and you're going to have this PDF. The first thing, these are things that are nice, like nice as in they give you points on your homework if you were to write a script. Are they necessary, strictly necessary to make the script run? No. Script will run without comments in it. Okay. Every comment is, MATLAB knows it's a comment. How? The first character is a %sign. Makes everything green. First of all, I put the name script in the first line. See how it says script file, Fahrenheit to Celsius.m. So when I'm reading it later, I know this isn't a function. I don't have to worry about different workspaces, which again, I will get to before this class is over. A purpose is very nice. This is all just good engineering documentation. This really isn't programming documentation, by the way. This is good engineering documentation for any kind of report or thing you create. It would also tell you what the input variables are, what the output variables are. There is a break there where there is no % character, it's just a blank line. What does that, actually this is, I guess, I don't know, did you do this in 112? Why would someone do that? No good ideas. That means we didn't do this in 112. That's fine. If I was to type in help, you often type this in MATLAB, right? If I was to type in Fahrenheit, not Fahrenheit, okay, if I was to type in this, notice at the very top was where I typed in help. It lists out some things. What does it list out? It lists out all the comments you had in that .m file until it reaches a blank line. And then it doesn't print anymore. Why would somebody want to do that? If somebody was writing this very helpful script, because, you know, it's hard to calculate from Fahrenheit to Celsius. If someone was to write this very important script and intend it for use for somebody else in MATLAB, then you might want to write this stuff at the beginning to let someone know what it is doing, your script is doing. But then there might come a point where you'd like to write some other things, some comments to yourself or, you know, whoever, and you don't want people to see that. So, you know, you're in an emotional moment and you want to type, I love my grandma. I feel like I should put that in my script. And so you leave the blank line, and then I love my grandma won't be in the thing. Normally you don't put that in a script, but you can. The kinds of things that you would put after there is maybe a record of when it was created and when it was revised. Maybe acknowledgement if necessary. Look, this is so professional engineering documentation. Even though this could be possibly, you may never run this in your life, nor should you. I still put an acknowledgement in there that it came basically from somebody else's book. Okay, that's just good engineering documentation and referencing. Okay, I wonder if you have questions about this. Lots of little subtopics today, and they all come together, of course, in the end. Let's come back here. What happens when you type which Fahrenheit to Celsius? You should know, but you should try it. But you should know by now it will give you, since it couldn't find a variable there, but it would find a file, it would just give you the whole path of that file. .m. The variables in a script, they stay in the base workspace. Okay, something is wrong. I'm just going to hide what I'm doing from you for a moment. For all you know, I could be going to Twitter and doing some tweeting. Okay, this is just a list of the things that we just talked about. The script declaratory is just that first line that says script, Fahrenheit to Celsius.m. A purpose. Why did I write this? Input variables. In scripts, you may not have input variables. Some of this will make more sense after we've done functions. Output variables. Blank line in comments. Why? Because I don't want everyone to see that I love my grandma. Well, I'm not embarrassed if they know that I love my grandma. But they're just things that the average user wouldn't want to see. Program history, when was it written, when was it revised, etc. And acknowledgement if necessary. Okay, so all these things, and by the way, when we do functions, you're going to see basically the same set of things. These are great things to have in your .m files, in your scripts or functions. In fact, they will earn you maximum points on your homework. Just winked at you. Points equals, no, by the way, this equals full points. So that's a good. That's what was going on. You have no idea why I just said that, and that's fine. Don't worry about it. Okay, so that was scripts. Now a new thing, very much connected to all the old things that we've been talking about so far. Functions. Functions are much different. Functions look very much like scripts, and that's what causes some of the confusion. How are functions like scripts? Functions are like scripts, or how are they alike? This is like back in high school. Contrast and compare. You love it when your teacher said that. That was a fancy way of saying, How are they alike and how are they different? Functions and scripts both are files, separate files that end in .m. They are things that are essentially separate from MATLAB, but not really, because I run them from the workspace. Okay. The main difference, and wow, this is the thing. This is now where we're getting to the point where half of you will be confused, and that's okay. It just means that I want you to come and ask me questions about it. The variables created within a function stay with the function and do not show up in the base workspace. I kind of wish I had said that a little bit differently, so now I'm going to say that a little differently right now. When you run a function, basically, you can think of it as MATLAB. When I type in the name of the function, not script, the function, MATLAB jumps into the function. And now you're inside the function. Like, pretend you're in slow motion. Once I'm in that function, you're in a new workspace. That's what I really want to get across. You're in a new workspace. You are no longer in the base workspace. Variables that you create inside the function do not show up in the base workspace because they are in the let's just call it the function workspace. Turns out you actually could be running several functions at once, not that you necessarily want to for this class, but you could, and then you would have many workspaces, each one with a collection of variables. But for now, let's just think of it as you have the base workspace, which is what you're playing around with when you start MATLAB, and the function workspace, which is what happens when MATLAB jumps into that function. If I had rewritten that whole Fahrenheit to Celsius thing and had almost exactly the same thing, then the main one of the symptoms, one of the manifestations of that difference would be when I was done with the function and it passed back to MATLAB, I would not see Fahrenheit C and, no, temperature C, whatever those variables were. Temperature C and temperature F would not be there. That's because they're back in the function workspace, not in the base workspace. Okay? I wonder if I can I clarify anything that I just said there before we talk about it a little bit more? Yes, absolutely. If I, let's actually, let me see what is going to happen next. Okay. Let me go backwards. I'm going forwards. We are going to talk more about what the function looks like. And again, realizing that you may have done some of this in 112. For now, let us pretend that this is a function. It meets the right, pretend it is a function. Okay. And it's once it starts coming to this, once you type the name of the function in Fahrenheit to Celsius, it jumps in here and it starts doing these statements. When it gets to this one, it says temperature F equals something. It's asking for temperature, so it's going to do an assignment statement on temperature F. Temperature F is a variable that exists in the function workspace. It does not exist in the base workspace. The base workspace knows nothing about the function workspace. So it does all of its work, and it works within a function workspace. And then when it's done, when it gets to the last line, it comes back to MATLAB, basically the MATLAB base workspace, and it leaves all of the variables that it may have assigned in that function workspace behind, and you don't see them anymore, nor can you access them in the base workspace. Okay, how's that? Great. I love clarification. That's a great question. What else can I say about that? Well, I'll say a little more. I'm going to keep clarifying and clarifying.
So as far as nothing changes the way it runs, right? That's just where you're seeing those variables at.
That's right. Exactly right. Good. There is a huge difference. And that is, how do we talk back and forth to each other? And that is where we get into, I may modify a lot of the statements I make on this thing, but that's fine. Okay. Basically, the rest of the time, the concept I'm trying to convey to you is, okay, we already talked about how would you run a function. You would type its name from the command window from MATLAB. But when you're in the command window in MATLAB, in what workspace are you in? Base workspace. Now, when it goes off into its function workspace, I already told you that these are two separate buckets, two separate sets of variables, right? The main thing I want to get across for the rest of the time we spend together is how we talk back and forth to each other. That is the crucial thing. But maybe I want the function workspace to know something about what's going on inside the base workspace, so how do I do that? And the answer is input arguments and output arguments, okay? So that is what we want, and that is the big difference between functions and scripts. So functions, they accept inputs. Better said, they accept input arguments. Well, that's the next bullet point. There may be more than one. We will call them arguments, input arguments. And then they just do whatever they do, assignments, asks, do statements. Remember, there's no, I just made that up, right? But that's okay. And then they will assign outputs. There may be more than one. And the crucial thing that at the start here, when it says accept inputs, what I'm really saying is I'm telling that function workspace about something I want it to, about a variable I want it to know. And then at the very end, when it says assign outputs, what that really means is the function may do some calculation and make a new variable. And I might be interested in that variable when the function's done. So I want it to be visible in some way, or I want to be able to access it in some way when I'm all done with the function. That is the purpose of the output argument. So these are just ways of passing things. In fact, that's how we say it. We pass things in, we pass things out. Those are input and output arguments. This is called real-time class changing. There's some things I really don't want to say yet. If I spend more than like 5 minutes doing this and looking down, just leave. I probably won't notice. I'm going to try and do this in like 30 seconds. Yeah, what I really want to do is skip a little bit and jump right to, it's too fast. Let's see if it's here. Please be here. You're not here. Ugh. It's fine. I know where you are. I know where you live. And I can find, you know how you talk to your computer. Oh, yeah. Yep. Okay. Here's another thing that if it is not in your Canvas folder, it will be. So I don't want you to think like I've got to write down all that stuff. No, because it's going to be given to you. Basically because I love you and I don't want you to have to, write down stuff you don't write down. Okay. Here's a fun function that does something that you did back in junior high. It finds the quadratic roots of a quadratic. And this time it is a function, not a script. But notice on first glance, they look the same because it's a bunch of colored statements in a .m file. That's how they're the same. I've compared them. How do I contrast them? The very first word in this .m file is what? Function. And that is how MATLAB knows it is a function, and keep those workspaces separate and, you know, jump into the function and don't worry about the base for a while. That's how it knows. Okay? Where are these input arguments and output arguments? They're right at the top. Notice the way, this is called the syntax of how we talk about a function. The syntax is the word function, right? Tells MATLAB it is a function. Now the next thing that's there may not be what you think it should be. The next thing that is there is what we call the output argument. This is the thing or things, singular or plural, that we want the base workspace to know about when we're all done with the function. Whatever those things are, that is the next thing that goes here. In this case, it is a single variable which we are calling quadratic roots. That's not a bad name for a variable, by the way. I'm pretty sure what that variable is holding. It's holding quadratic roots. I might want the base workspace to know about more than one variable when the function is done. If I do, that's fine. I would enclose this in a square bracket, put a comma, and then put another variable, a comma, and then as many variables as I want, and then close with that. Okay? So again, if I want the base workspace to know about more than one variable that's created here in this function, then I would enclose it in square brackets. Really important, right? Because that's different. But in this case, there's just one. And if there's just one, I don't need the square bracket. You could put it in there, but you don't need it. Okay? What is the very next thing on that line in the syntax? It is an equal sign. This is obvious. These are output arguments. This is an equal sign, but you've known that since kindergarten. What's the very next thing I see? The very next thing I see is the name of the file, which is the same as the name of the function. So this function is called find_quadratic_roots. That means it is stored in a file called find_quadratic_roots.m. Find quadratic roots. And then the very last thing is a list of any input arguments I want the function to know about that I'm going to send it or pass to it from the base workspace. Now in this case, it doesn't matter if there are 1 or 100. They must be enclosed in parentheses, curved parentheses. So for sure, even if I've got just 1, I'm going to put parentheses there. And if I have more than 1 or whatever I have to put in there, I'm going to separate them by commas. Input arguments. And we probably just should say that, are those good names for variables? No. So we should put that down. Horrible names. Horrible. You know, if like you're really into it, you know, you're talking like you're doing MATLAB, unforgivable maybe, whatever else names. So use use better names than those. What are those actually? Well, those, it's going to turn out that these are the coefficients of whatever quadratic that I'm trying to find the roots of. Okay? This is, again, what is this? This is the syntax of how I tell the .m file I'm asking you to be a function. And this is how I'm structuring you so that you will know. Okay? So before we go on, I wonder if you have any thoughts or questions about that. Yes?
Would those input arguments be perfect? Because they're describing exactly what the formula is.
If I knew like well in advance what I'm doing, which you should never assume, especially if it's me, then yes, maybe. But something better might be, even though it seems tedious to type out what would be better ones, something like quadratic coefficient, linear coefficient, I mean something like that. Then there's no ambiguity at all. Okay, good though, good. Love it. What else? What else can I say? Okay. Now, please let this be a real thing in MATLAB and not just a PDF file, or that will really rule. Look how angry I am. Which, I don't know if that, why did it do that? I guess because my pinky hit the thing. Which, no, not Fahrenheit. I can't type that anyway. Which find quadratic roots. Oh, look at that. Oh, good, 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 good. Okay, now let's talk a bit. By the way, did we write functions in 112? I wonder just how much I'm boring you to death. Some of you are thinking, you're boring me to death, and I didn't do this in 112. Come on, work with me here. Okay, so I'm getting the sense of not enough that I feel really good about going out and writing my first function. Okay, great. Now, then let us talk about then how we launch this thing and do the whole passing back and forth business, okay? Question? No, doing this, okay. To run anything, function or a script, I simply type its name, right? If it was a script, that's the end of the story. If it is a function, then I need to start thinking about input and output arguments. So I'm going to launch this bad boy from the command window because that's where I launch any script or function. But I'm going to do it in such a way that I get the whole passing back and forth right, okay? So that's no longer up there. Let's take one more quick look at that. I have quadratic roots should be the output arguments, and the input arguments, there's 3 of them, and they represent the first, second, and third coefficients of some quadratic. So I would type quad roots equals find quadratic roots. What's a good polynomial to do this for? What's one that I know the roots for? Let's say the roots are 1 and 2, like x plus 1 and x plus 2. I guess it's x minus 1 and x minus 2, which means it's x squared minus 3 plus 2. X minus 1 times x minus 2. No. I don't even know if that's right. Doesn't matter for the moment. Okay. This is, I haven't pressed enter or anything yet. But this is how I would launch that function and start it. I've done some pretty important things in this one statement. For one, I'm launching the function find quadratic roots. That's a given. I am passing it the numbers that I want to be. Once it gets into the function, I want it to be equal to a and to b and to c. And I've also specified at the very beginning where I want the output to be stored in a new place called, a new variable called quad underscore roots. Okay? So, when I hit return, what happens? MATLAB not only starts the function find quadratic roots, but it also sets a equal to 1, b equal to -3, and c equals to 2 in the function workspace. And then it proceeds. Okay? As it proceeds, if I look down this file, I don't know if you can read that or not, but I'll tell you what's happening. It figures out, you remember finding roots in algebra, like way back in when do you do it, 3rd grade or whatever, whenever you do it. And you find the discriminant, that's like a super cool. And the discriminant is positive, negative, or 0, and that depends on whether you have 2 real roots or 2 imaginary or you know, a repeated root. Okay, it's doing that. It finds out what they are, and then it stores the roots, the 2 roots, in a vector, and it calls that vector quadratic roots. So within all this stuff it's doing, it's always, in the function workspace, it's defining a variable called quadratic roots, whether the discriminant's positive, negative, or 0. So now, before the function is done, no matter what, the function knows, the function has a value for A because it was passed in. The function has a value for B because it was passed in. For C because it was passed in. Based on A, B, and C, the function defined a new variable called quadratic underscore roots. Okay? And now the function's done and it's ready to be finished. Look back at the structure here. What is the very first, well, actually, there's the second thing that I put was it matches that name, quadratic roots. So that would be the output argument. Okay? That tells the function that it is intended to pass this value back to the base workspace. Okay? How does it do it in a function? Now I go back to the way I am calling the function. The way I called the function is the very first thing I put there is where I want that output argument to go. Notice that that name does not match my function's output argument name. Does that matter? No. Why not? Because those are 2 different workspaces. And what goes on in one workspace doesn't have to match names of what goes on in the other workspace. It's just passing it a value and say, you can put that in any old name of a variable you want. I knew it as quadratic roots, which was a great variable name. But when you go back to the base workspace, if you want to call it X or whatever, that's not my problem. That's so, you know how functions talk to MATLAB. Anyway, in my mind, that's what they're that's what it's doing. If I hit return, what happens? Well, the function itself, apart from the whole passing back and forth, apart from that, the function had a little statement in that said print out what the roots are. It wouldn't necessarily have had to, okay, but it did. In this case, it did. The important thing is I look up here and I see this new variable called quad underscore roots. Where'd that come from? It came from being passed back from the function. Where are A, B, and C? Here's a good bonus quiz question for you. Where are A, B, and C? That's right. They're in the function workspace. And to be more clear, when the function is done, whatever variables was in its workspace, it gets rid of. So they're actually eternally gone. So if you're hoping to save A equals 1, you're done. Okay, so it's all done. All right, boy, that's a lot of words.
Precision on those numbers, is that dictated when you're writing the line, whatever code, or is
Yeah, it's a good question. In this case where the function printed out something I told it to print out, it is set by inside the function. So I told it print out 6 or whatever decimal places. It's a great question. Yes, yes. So what I did is I started my, let's call this the launching statement, because that sounds kind of cool, almost like I might shoot through the ceiling. The find quadratic roots function, my launching statement said, when you're done, give me back that output argument in a variable called quad_roots. Inside the function, it must have a matching statement that says, I'm going to give you back something. The only thing is that the names don't have to match. But when somebody writes the function, they need to know that they're expected to pass back something to the base workspace. When somebody calls that function from MATLAB, they need to know how the function was written so that they know that they should be expecting something to come back. How's that on now?
Yeah, so when you first start your MATLAB, it runs a function in the other workspace, and when it's done, it'll bring back the output.
That is correct. That is correct. Good, 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 good. What else?
So then if you didn't put quad_roots equals your function, would it just give you the ANS equals?
That's right. That, yes. That's, okay, this is our trash can. This watch buzzes at me, and when it buzzes at me, it says move, exclamation point. It does?
Yeah.
The thing is, Mrs. Bashford gave me this watch, and she said, I think you will find it useful. Those were her words. We're going to put this on something soft and get it away from here. It does that like hourly. I want to say, no! You know, you talk to your, but then I'd be talking to my watch. I've talked to many objects in my time, but not my watch. Not yet. Okay, what else? There's a lot more to say, unfortunately or unfortunately. Not a lot more to say. I can clarify from different angles. I don't expect this to be a, oh, I get it concept right now. This is really something that I want you to look at and think about. Now, maybe some of you are super geniuses or a program before or whatever, and you know the concept of input arguments and output arguments is great. You know how to get them in MATLAB and all, fine, fantastic. But I'm betting that the majority of you don't, and so I counsel you to think about that. Now, your question is a fantastic one. Let us just look at that for a second. What if I did not explicitly ask for the output argument? So in other words, I just typed in find quadratic roots 1 minus 3, 2. And I hit return, so what happens? What happens is the function, it goes into the function and the function says, you wanted something, you wanted something. I'm giving it to you whether you want it or not. And so the base workspace says, okay, I'll take it. And if I don't know what to do with something, I automatically stick it in a variable called ANS. That's what happens. Okay? Gets a little more interesting if we have more than one output argument, but we will look at that in a second. Notice how I clicked, I had a semicolon, so it didn't show me, but ANS is now there, and it's a 2x1 variable. Okay, I like that. Yes, I am pleased with the slide. Next slide. Optional outputs. We talked about this already, but if you wanted to have a function that had more than one output, then it is not necessarily the case that that MATLAB-based workspace has to take all those outputs. What did I just say? I'm going to do. Best way is to do an example. But first of all, let's give you some background. In MATLAB, within its built-in stuff, there is a function, and the function is called max. And guess what max does with a vector? It finds the maximum. Surprise! The way that max is written is it's written like this would be function, and then all that stuff would be written there. And what that says is that max can actually give you more than just the maximum value. It can also give you the position within the vector from whence, it's like Shakespeare, from where that value came. So, first of all, let's look at that for a second, just running it as if whatever. Let me put a vector in here. X is a terrible name, horrible name, unforgivable name for a vector. Okay, we got that now. Because it's already 5 o'clock and I'm not going to do much math after that, I made the maximum value of this vector very clear so that I would know what it is, okay? I think the maximum value here is 100. Just as importantly, within this vector, 1, 2, 3, 4, 5, I know it is the 5th value, right? Okay. So let's just start with that. And let us say, if I want both things back, then I might say from the command line, again, I want to call the function max, and I want both those arguments back. So in square brackets, just like in my function, I'll say max value and max index, that is where the maximum is, equals max x. Okay? When I do that and I hit return, I should have 2 new variables in my workspace that say max value, and if I'm looking here, I don't see its actual value, but I promise max value is 100 and max index is 5. So those 2 things are there. Okay? So that's how I would call a function which returns more than one argument. I need to enclose what I want back in square brackets. Okay? Now, I started this whole little rigmarole by saying those arguments may be optional. Okay? A lot of times I may not want to know where that index is. In that case, I can just say something like max value equals max x. What happens if I do this? MATLAB's a little bit forgiving. The way I've written this, what I want to have happen from the base workspace doesn't quite match what that function definition statement is. That's okay. MATLAB says, all right, I guess you just want the first thing back. And it would give it to me. Okay, so in other words, another way of saying that is, do I always have to take back the index position of where the maximum value is? No, I don't. That's okay. So output arguments are often optional. Okay? Questions on that? Slightly new topic, but still very much related to the whole business of something like functions. Sin. SIN is also a function within MATLAB. Then it's built-in stuff. what does it do? You pass it an input argument. And what it does is it takes the sign, the SIN of every element within that thing, and sends it back to you. So maybe I should give this a, if I wanted to, I could give this an output argument as well. Now, there's one very simple thing to say about this. What is the size, when this is done, what is the size of y? Say again? Good. In other words, it is the same size as x. Okay? So if we have operations, functions, that operate on every value in a vector or matrix, then what comes back, the output argument, will be the same size as the input argument. Okay? That's it. That's the end of that little subtopic. Okay? Many functions give you an output that is the same size as what you gave it. Sine, cosine, all the trig functions, e to the something, log. I think you get the point. All right, finally, we want to take all of this and create a nice big juicy function. We want a nice big juicy function for homework that we want to write. Okay, so let us talk through what exactly we're going to do. Good function oh, it already says that. I'm giving you that. You already saw that. You already saw that. You already saw that. Algorithmic top-down design. When you're doing algorithmic top-down design, this is the same thing as doing any kind of engineering design. You start with a large, I'm going to fly through this, by the way. If you want the answers later, great. But I want to get to the homework. Start with a big picture. Clearly state the problem to be solved. Define the inputs required by the algorithm, the outputs required by the algorithm. Design it so it solves the problem. Write the steps on paper. This pseudocode is very good for starting, if you're writing a big juicy function. This pseudocode could become your comments. And then all you do is fill in the comments. Turn the individual steps into computing ask-assign statements. Okay, let's put it all together, and this is going to be a nice, good homework for you to do. Have you heard of the lifeguard problem? The lifeguard problem is like this. You're standing somewhere on the beach, minding your own business. You see somebody in the ocean and they're in trouble. And so you say to yourself, I think the right thing to do would be to go save them. So you head out to save them. The thing is that you can run on land faster than you can swim in the water. So the optimization is, where do I go in order to reach the person at the least amount of time? Okay? And the answer, if it's different, your run speed on land and your swim speed in the ocean, if it's different, the answer is not straight to the person. Okay? Now, in this kind of scenario, there are all kinds of variables we could play with. You're a certain distance from the beach. The person is a certain distance from the beach out into the ocean. Okay, that kind of defines a grid of where people could be. What you want to do is, you want to head for some point on the beach, which again minimizes the time it takes for you to get to the person. Now the question is, how do you do that? Well, if this was, and this is crucial difference about to come up. If this was calculus class, what would we do? We would write out an expression of time, and in it would be the variables of how fast I can run on the land and how fast I can swim in the ocean. And I'd have one expression with time. And then I would, what, differentiate it? That's how we optimize. Set it to 0, find an inflection point, and do all that good stuff, right? This is not how we would do it in MATLAB. We will do it in MATLAB a different way. In MATLAB, what we are going to do for this assignment is we are going to test all at once all of the possible ways to get to this person. Not quite all the possible ways. Let me go a little farther and explain what I mean. Let us say that x is the distance from you up the beach that you could head to in order to get to this person. Well, now if I know the distances and your rates and all that, I could write some sort of expression that says this is how long it would take. There's an associated angle there from the ocean, an associated angle with the land. What we are going to do, there's like a well, there's a continuum of x's that we could head for, right? What we are going to do is pre-select a whole bunch of them. Basically sample a whole bunch of places that we could shoot for. So when you write your big juicy function, your homework, the way you will start is by saying x equals 0 in steps of, it'll say on the assignment, I don't know, 0.01 to the maximum, which in this case is capital D sub V. Okay? Now think about that for a minute. What did you just do? You set up a vector x that holds a whole bunch of places that you could, well, if I look away, I start meandering, that you could head for. In each one of those cases, each one of those elements of x, it would take you a different time to get to the person, right? Because each different place means a different, time it takes to get across the beach and then a time to swim across the ocean and so forth. What you'll do is you'll calculate all those at once. So in other words, this is your general idea is to have this big vector x, which x is a terrible name. Don't pick that. But I'm going to because I'm teaching. The most straightforward way to do this is to say, let's create an equal length vector. Don't name it time because time is a special name in MATLAB. Well, skipping a few steps, but I'm going to fill them in just a second. If you had for each element in x, the time it would take to get to the person if you headed for that place x, and now you had this time vector, what would you do then? Find the minimum. Excellent. So in somewhere in here, you would find the minimum, right? Let's pretend it's here. And then that would be the minimum value. So that is, now here's what's important. That should correspond to where you head. But how do you know where to head? Because the problem is not, tell me the shortest time it would take for you to get there. That wasn't the problem, was it? The problem was, where do I go? So how would you get that? When you use this minimum function, you also need to know where in this time function it is. Because that location should correspond with, that's what you want to know. That's what you want to know. So you will need to pull out to address, to ask for the x location at the index that equals this minimum time. Okay? So the couple of steps I left out was, well, you may want a few intervening vectors. So for example, you might start out with x, and then you might have a new vector that says distance, pretend I wrote distance to shore. And then it would be a vector just as big as x. But it would be much easier to calculate because you'd have to use like one trigonometric function to figure it out. And then the next one, you might have several vectors that just kind of help you build up to where you're getting. So distance to shore. Time from me to shore, same thing. Distance from x to swimmer. Time across ocean. Then total time, add together the times across land, across ocean, and then find the minimum. Okay. And that's it. So, I wonder if you have any questions about that assignment, what you are going to do. Well, you should read the assignment first and then, and then ask. I'm just giving you the basic outline. You're going to write a function, and the function is going to take as inputs dl, dd, db, but much better names for them. Your rate of speed on the left. So there's a whole bunch of input arguments as you gave this function. And then you're going to want the function to output one or more things depending on what the assignment asks you to output. Okay, questions? I will stick around for a little bit to answer any possible questions I can on any homeworks, upcoming or past, quizzes, whatever. If not, I will see you next time.